Yes, sir.
North of... May mga 3 minutes na lang tayo na. Hopefully matapos taas ng number 2. So I think the idea of our graph, guys, is just for us to picture out how to correctly make our equation also. And then this one is still the same thing, almost exactly the same. So how about our graph or diagram for number 2? How do we illustrate number 2? So if you'll use a mathematical approach there, because they are perpendicular still. So one is it moves north. The item tells us that it goes north. Sorry, I'll just change the color. So the first value is it goes north 15 kilometers per hour. After that, it goes what direction? Westward, Westward 8. So north and west, So therefore, diri karon siya makita sa wala. So our drawing now will go left. And therefore, how do we get our VR or VR? Now this time it's velocity. So ano ko ng resultant velocity? So VR. So still by Pythagorean theorem, that's 15 square plus 8 square and square root of that value. You may even skip the use of the scaling, as long as you know and you are oriented correctly. So first of all, we go north 15. So we are on number 2. So a ship sails north at 15 kilometers per hour, but drifts westward with a tide at 8 kilometers per hour. So you'll notice if something is sailing on the ocean, there's another tide that will try to move it in a different direction. So the ship's captain has to navigate it in such a way that they will not be directed towards the flow of the tide. So hindi sila magdugayan. So they have to steer the rudder of the ship in the right direction. So this is 15, assuming this is going north. The next value is it's 8. So maybe a little half of 15. And then the third value is our resultant now. So this is our resultant. So the resultant can be solved, guys, by using our protractor. But however, our angle can be directed in this way, so that the angle theta, we can see it and have it on this location. So our theta is equivalent to an angle there and again our what do we call this? VR, resultant velocity. Resultant velocity is 15 square. And the value now, we have a value already. How much is our value there?
17, sir. 17 kilometers per hour, sir.
17.9. Excuse me. What's wrong? I'll just mute the class, the entire class. Okay, I mute all of you para hindi na lang mag-down. So we go to this one again. So I heard a while ago an answer. Pila ganitong answer. So can somebody unmute themselves? I did not. You can still unmute yourself. Pila itong sabat niya?
17 kilometers per hour, sir.
Exactly. Wala sang decimal point.
Why, sir?
17. Okay, 17. That's kph siya, or kilometers per hour. Na? Sige. So let's just be consistent with the one that we use on the example. No? So again, now what's missing here? We have to write our square root symbol. Sorry. So square root symbol. Let's have our square root symbol. And we'll write our square value. So that gives us 17, no? Tama? And then, how about the angle, guys? How do we get the angle? So theta is now arctan of, so our opposite side here will be the one which is 15, and the adjacent side is 8. No? Okay, now, the angle that we will get will be, obviously, this will be north. So some values that we'll get there will be north of our west, since it is located on the left side. Can somebody give me the value?
62, sir.
Point, any decimal.
61.9. 61.9 siya pala, sir.
Okay, sige. Amo na lang na 61.9 degrees north of east. So again, this is our theta value. So the angle over here, so this is the one that we have. So this, since this is west and this is north, so this is north of your west, ang aton nga angle. And then remember how we completely write our displace or our vector, guys. So if you have there BR, we usually write it in this manner. So 17 kilometers per hour at 61. Okay, so that's how we write our whole value. Okay, so do you have a question, guys? Do you have a question?
None, sir.
No question. So very good. So let's pause for a few minutes and we are going to continue our discussion. So that covers our seat work there and hopefully you have your answers there we are going to go next to our new topic on the components of a force. And again, the idea here of the arctangent, our trigonometric functions, we are going to use them again in our discussion on the component. So the components of a force. Sige, so it's loading. So let me erase this one instead. So we will clear our screen. And we are going into our next lesson this morning. And this will be about our components, components of our. So we call this basically as components of a vector. And I will say that the components of a vector, there are two. There are two components I will call the first one as the horizontal component. So the first value is horizontal. And sometimes they call it, guys, as the x component, no? So that's one term that they use. So it refers to the x-axis, and then the other one is the vertical component, or this is basically the y component, no? Okay, and then if we are going to use a force, or kung magamit kita sa word being a force, guys, no? Then our x component could be called fx. Our y component can be called as fy, no? Depending on, again, the vectors that is used. No? If it is a distance, then it is dx, dy, no? So going through now with these slides, no? So we have components of our vector, no? So we are going to find, no, is to find the x and the y components, and eventually determine the resultant of maybe not only two vectors, but this time 3, 4, 5, no? Depende sa number of vectors, no? But we will use the components, no? Now, if we are dealing with this car, for instance, no? Allow me to explain now this car. This car is, let us say, no, is illustrated to be traveling at a certain speed, no? I'm not sure if it is given ang speed, no? But again, now if we are dealing with a car, supposing the given, no, there's just one given value, no? So the velocity of the car is, for example, no, 50 kilometers per hour, no? Ang iya value. And then it is moving, no, at a direction 30 degrees north of east, no? So similar to what you are seeing now, no? So it has a certain velocity, no? And its direction is also provided. Now, what are these values x and y on the sides, no? So probably now, if this is our v sub r, no? So our v sub r again, no, is this value. So that's our VR, no? And that value again is 50 segments, no? So this value over here is 50, no? So question, how about the two sides here, no? If we know the angle to be equivalent to, if we know the angle to be equal to 30 degrees, no? What will be the two other sides, no, na value, no? So again, no, our angle is given to be, no, 30 degrees, no? Now this time around, what we are looking for are the y and the x component. I can call this x and y component as vx, no? And this other end as vy, no? So vx and vy are my vertical and horizontal components. So basically, this is a triangle where this one is your v value, and these are the components of your v, no? Now, if you recall your SOHCAHTOA, guys, no? We realize that if we are going to get the value of sine, the sine of the angle theta, no? That is always the opposite over the hypotenuse, and the opposite side in this